Hello, 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 Internet. Welcome. Welcome to another NL Math Man Math Help stream. Let me just put myself back up here. Here we go. Great. Yeah. Hope everyone's still doing well with their distance teaching here. Welcome to day 21 of my math stream. Today I've been rather extremely busy. I'm always busy in the morning, believe it or not. Like it's crazy, right? Like how can someone be busy during social distancing? It's crazy. Like nobody's doing any work, right? Nothing. Unless you're an essential worker, right? Essential workers are doing doing a shitload. Crap load, poop load. It's a G-rated stream. Um, but yeah, I mean, teaching, they say that teaching right now is either like you're doing absolutely nothing because your district and your school and your principal and whoever else has figured out like literally nothing to do for distance and you're just sort of twiddling your thumbs and hoping, or you're just run off your feet crazy busy, right? I'm more on the crazy busy side, but it's partly my own fault seeing, this distance teaching method that we're using in the college I teach at is, my design, right? Like it was kind of mostly my fault that I'm that I'm as busy as I am. It's mostly my fault. It's a solid 75% my fault, 80% maybe. But whatever, mea culpa, I guess, right? There's worse problems to have. I could be just, you know, doing absolutely nothing and just sort of, you know, I don't know, waiting for my next NLC order, I guess. Yeesh. It's a bit grim. It's a bit grim off the start. Let's start this one again. Go to hello, 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 internet. There we go. Welcome. I'm 3 minutes late now because I had, for some reason. We'll just start this one over. But over here to the side, we see a very nice picture again. A very nice picture of the little furry people, little furry flurry and pokey smoky. Very nice doggies. This one is about it's about 4 years ago. Yeah, it's about 4 years old there. So Flurry's about 5, and Smokey's about 2. Yeah, he's only a little fuzzy boy, just fully growing there, just kind of, just. And Flurry's there. She looks a lot younger there than she does today. Um, you can see on Flurry, especially now as she's gotten older, there's these little um, sort of like black drainy bits. It's like sleep, or I guess whatever sort of residue comes out of their eyes when they're sleeping. It's sort of gone down across here and has made these sort of dark marks going down her cheeks. I'm told a lot of labs get that. A lot of dogs with light color fur get it. But you can see here, you can sort of gauge her age on the picture by how pronounced like the dark marks out of her eyes are. And in this one here, you can see that it's fairly small, so we know that she's quite a bit younger. Also, I just know when the picture was taken. Believe this one is out behind Gander someplace. Just I clearly cutting wood. I guess my parents do have a wood stove in their house in Gander. I think they have like every stove. I think they have. I don't know if they have oil, but they definitely have. No, they do have oil. They have wood and oil and electric. Because you gotta keep warm, right? You gotta keep warm. You gotta keep warm out of the sweat of your brow, right? Go out there and chop up some wood. Oh, chainsaw, not really chop. I guess it is still kind of chopping. Anyway, just ramble with aimlessly with no point for 5 minutes or so, and then start talking about some math. Seems good, right? Seems good. I considered having a title today where I would mention like sunlight injections or like drinking bleach or whatever. I don't know. I don't know if I even want to touch that stuff. Like I know I'm a few days late, running behind the news cycle, but boy oh boy, boy oh boy, I don't honestly don't know what to say about that. Like it's just it's like a scene from Metalocalypse, right? You know, bleach is mostly water, and we are mostly water. Therefore, we are bleach. My best Nathan explosion impression. I'm sorry, any Metalocalypse fans or anyone with ears who was watching. Anyway, I'm going to start in with the math here now. Before I get super sidelined with nonsense. We're going to talk about surface area of prisms and cylinders. This will be my first topic today. Going to focus on rectangular prisms and then cylinders, and we're just going to go down through sort of break apart what the formulas mean, what the different parts of them represent. Graphing systems of equations. I'll do a little bit on that on Desmos again. And then some mean, median, and mode word problems, just to show again some of the I guess the more complicated bits that we might be asking you to do based on these topics that you already know, right? Okay, so let's switch on over then. Let me make sure that I've got my correct document up before I swap. Here we go. So we can see over here that my paper is off center. There we go. But we can also see that I've got another page here from mathaids.com. Very, very helpful math resource site. I'm going to pick a few of these and do them, a few on each different topic. So I'm going to go over to this display then, and I'm going to zoom in a little so we can see it a bit better up in the corner. Now this is for Ashley's work here. So I have sent you this sheet already. This is not one that you're expected to do for marks. So I'm going to feel free to just go through and do out as much of this as I can. Right? This is going to be Math 1102A, Unit 3 review. So we're going to review a few of the topics from Unit 3. Do question 1 here. Now, question 1, right, is going to be the surface area of a cylinder. Right? So we know, well, whenever we do a test or an activity or anything like that on one of these topics, we're going to have a formula sheet available, right? So then, boy, oh boy, this is like, my camera is really having a hard time. Look at it, like my face goes back, alternates between like red and gray. Look at this. Look, this is going to happen again? I don't know. Weird. The color is just all over the place. I don't know. The lighting in this room must be real troublesome for that camera. Anyway, the surface area of a cylinder, right, is going to be 2 pi r squared plus 2 pi r h. Now, if we were to look at word problems on this same topic, which actually maybe it's a good idea. Maybe I will look at a word problem on this same topic now in a second. But for those, we have to know what parts this stands for, right? So this pi r squared we know is the area of a circle. We know that one. So then 2 pi r squared is going to be the area of top and bottom. Right? Because when we're trying to find the surface area of a shape, all that is the area of all the faces added together. Right? And then we've got 2 pi rh, which is the lateral area, or the area of the sides. I'm sliding off, aren't I? Area of sides. Well, that's harder to see than I wanted it to be. Okay. Either way. But here now, we've got 2 pi rh to get the top and the bottom. 2 pi rh to get the sides. 2 pi r squared to get the top and the bottom. So the surface area of this first one, then all we got to do is plug the units in where they're supposed to go. So 2 and pi is always the same. R here is 5 because it's the radius. It's 2 pi. The radius here is 5, and the height is 6. Okay? Now the next little wrinkle, right, or the only other sort of part that's sometimes confusing to people is the squared here, right? And so, of course, we have to remember that the squared is not times 2. The squared is this number in the corner like that. See, on my calculator, it's this button here, x squared, like that, right? What it might look a little bit different on different calculators, but what that is it's not 5 times 2, rather it's two fives times together, right? So it's actually 5 times 5, right? So this is going to be 2 times pi times 25, and this is going to be that's 2 times pi times 30, right? Now I'm going to leave this in terms of pi like I mentioned before, because this is all a super neat one that we can just work out easily enough here. 2 times 25 is 50, 2 times 30 is 60. So this is going to be, surface area is going to be 110 pi. Then I can just go and do that in my calculator over here. 110 times pi, 345.57. So 345, I'll call that just 0.6. And that is what units is that? Inches squared. And it's always inches squared or feet squared or meters squared or whatever it is squared here. It's squared because squared means a unit of area, right? It's a square inch is an area that's 1 inch by 1 inch. Oh, today, see, look at this. Oh no, this is usually my invisible pin. My invisible pin has come back to the land of the living. Look, we can see it again. Whoa. Maybe if I move it closer, it'll disappear. There it goes. Parts of it are disappearing. Man, oh man. You wouldn't know whether I've been... Anyway, whatever. I don't know. I throw my hands up. I'll get the chroma key to work right eventually. Either way, my invisible pin is no longer invisible, which is very disappointing to me. Anyway, but if we scroll down over here, right? Here we go. There's the answer. 245.58. Okay, so they rounded it to 2 decimal places. Still, we're still good. Good to go. Right, so that surface area. Figured that one out there. So now let's go over to, yeah, one of these, a rectangular prism. So like question number 2 here. So we know that the surface area of a rectangular prism is going to be 2 length times width plus 2 length times height plus 2 width times height. Now, you might see these written in different orders, or you might see the combinations of them be a bit different on your formula sheet or any other, or if you say Googled the formula. But the important part is not memorizing the formula here. The important part is knowing what the formula stands for. And the reason why this is the formula is because, well, there's 6 here, right? There's 2 sides here, 2 sides here, and 2 sides here, because every rectangular prism has 6 sides. Okay, let me just open up my math set here. Grab out a straight edge, and I'll just draw one out over here so that we'll be able to see a sort of small example of what it is that I am talking about. I'm doing single point perspective here. Sometimes, I mean, double point perspective probably would make a more convincing looking shape, but there we go. There's my sort of going into the distance rectangular prism. Don't mind this little bit sticking off. So then we know we've got, say if this is the width and this is the length and this is the height here like that, we know that we're going to have 2 length times width. Well, that's going to be the top and then the bottom, right? Because the area of a rectangle is just the 2 sides of the rectangle multiplied together. So we know the area of the top is going to be length times width. The area of the bottom is going to be length times width. The front is going to be width times height. Width times height is going to be here. And then there's going to be a width times height over here too, on the back of it, right? Because it's the same shape, because this is it's a rectangular prism. It's like a box, right? So there's going to be a width height on the front and a width height on the back. Now over on this side, this one over here, this is going to be a length times height, right? So this is an LH over here, and there's going to be another LH over here on this side in behind, right? So that's why we've got 2 of each of these combinations. And it's most important that you have each combination once. Length, height, width, height. The order doesn't matter, and the order of the terms within doesn't matter either. I could call this LW or WL, it'd be the same thing. But what matters is that we have each possible pair, and we double them in order to account for the fact that there's a front and a back, a left and a right, a top and a bottom. Okay? So now from here, we can just go and fill in our numbers. And as long as we're consistent with which number is which, we're good to go. So I'm going to say that my W is equal to 14, my length is equal to 7, and my height is equal to 8. And these are all CMs. So now, when I go ahead and do my surface area, I'm just going to have 2 7 times 14 plus 2 7 times 8 plus 2 14 times 8. There we go, right? So at this point, like, basically all the work is done. That's going to be 14 times 14, which is going to be 196 here. And that's going to be 56 times 2 is 112, right? 2 times 7 times 6. Oh, wait. 2 times 7 times 8. Yeah, 112. See, I'm better doing it in my head than I am doing it on calculator, right? My fingers are more likely to make a mistake than my noodle, turns out. Anyway, so 14 times 16, don't know what that is off the top of my head. 14 times 2 times 8, 224. 224 like that. And surface area, I'm going to go ahead and add these guys together. 224 plus 112 plus 196, 532 centimeters square. There we go. So let's scroll on down on that sheet. See if we got that right. There we go. 532.0. It's great. Now, Ashley, if you're watching this now, or if you're watching this in the future after I've linked it to you, I know on the previous sheet that I gave you triangular prisms. That was a little bit of a mistake on my part. You do have to do triangular prisms in this topic. You're just not doing it on this test. I had just thought that you were. But the reason that you're not doing it on this test is because that involves Pythagorean theorem to figure out the missing side. And you have done that before in the level 2 courses, but I don't think you've seen Pythagorean theorem again in the level 3 courses yet. You will, though. You will see trigonometry quite a bit in the level 3 courses. But for this test, it's actually just going to be these two, cylinders and rectangular prisms. Let's do a few more examples here of cylinders and rectangular prisms, just to get ready, just to get a bit more ready for when you're doing it on the test. Right? So I'll do a few more. If anyone in chat has something else on this topic or on any other topic, let me know. If it's on the same topic, I'll get to it immediately while I'm doing these. If it's on a different topic, I'll get to it next. But anyway, let me do question 3 here now. Question 3 is going to be back to cylinders again. So we've got surface area is equal to 2 pi r squared plus 2 pi rh. Now again, I strongly recommend writing out the formula every time. No, it seems like a pain in the ass, right? You're like, why am I having to do this every time? It's just on my formula sheet. But this is what helps you remember it. Let me tell you, oh, see now my green pen is disappearing. I've got a blue chroma key and my green pen is vanishing. The wonders of nature. But still, look, I do like this. Look at this. This is the floating pen cap. Anyway. Yeah, like I was saying, I really like writing out the formula every time because you never remember anything if you don't practice it, if you don't write it down. And by you, I mean me. Like anything I say about you remembering stuff, what I mean is me and my experience in memorizing things for courses. And let me tell you, I don't memorize anything unless I keep writing it out like this every time I do it. And, you know, this is how you get to that point. So I would say write down your equation first. And then we're going to start filling things in. So now we know that our H here is 6 millimeters. Now what's our R? Well, we know, is R minnow pause? See both sides of my mustache are practicing social distancing? Yes, they are. Look, look. Oh, no. Nope. Nope, nope, it's not. There we go. There we go. There we go. Now they're social distancing. Yeah, look at that. Good stuff. Oh, move that on over. So now we see that for this one, we don't have radius given. What we've been given is the diameter, right? So if we have the diameter, we know, of course, that the diameter is twice the radius. So the radius here is going to be 5 divided by 2. It's going to be 2.5 millimeters. Okay? So now we can go and take this, plug it in up here into the formula that we have for surface area. Just going to put this in a bit of a bubble over here so we know that that's not really on the side, but it is a part for the same question. Just going to keep it out of the way here so I got enough room to work. So 2 pi, I'm going to call it 2.5 instead of 5 over 2. I could call it 5 over 2, but you know. It's easier generally to work with decimals. We've got C, 2.5 squared. Right, 2.5 squared is going to be 6.25. So 2 pi 6.25 plus 2 pi, that's going to be 15. Right? So we're going to have 12.5 pi plus 30 pi. I'm going to keep doing these out in terms of pi, like I mentioned before. Personally, I prefer to do it this way, but you're free to use decimals from the start there if you would like. This is 42.5 pi, which is going to be what? $42.5 pi. There we go. 133.52. And that's millimeters. Millimeters squared. Again, right? Always important that the millimeters are squared. Now let's scroll on down. There we go. 133.52. Boom. Did it. We got them. Okay, what's another good one on here to do? I'll do one more, do at least one more rectangular prism. These ones, the cube ones, are a bit too easy, right? Because the cube ones are it's just the same on all sides, which is, you know, I mean, it's still reasonable to do. But 3 times 3 is 9, of course, so each of these faces are 9. 9 times 6 is 54. So we just scroll on down here and, hey, look, 54, right? Sorted. Done it. So now I'm going to move on over to, let's see. Yes, to this one. Let's do question 4. Question 4 again is going to be another rectangular prism. So I'm going to do 2 length width, 2 length height, 2 width height. Again, right, the order that I put those in or the exact combinations doesn't really matter. Now the width of this one, across the middle there, so it's going to be 11. And these are in yards, some sort of archaic, you know, caveman sort of measurement. The length here is going to be 8 yards, and then the height is going to be 5 yards. Surface area, right? So then we just got to go and fill it in. That's all we're doing here. And it's for the same reason up here, right? We had one on each side that was length height, front and the back is width height, top and the bottom is length width, right? And we got 2 of each of those. so that's 2 times, let's see, 8 times 11 plus 2, 8 times 5 plus 2, 11 times 5. Right? Just making sure that we've got all the different sections in there. Then we're going to have surface area equals 176, right? Because 88 times 2, or I guess 16 times 11. Either one's fairly easy there. 88 times 2 or 16 times 11. Over here, then we've got 2 times 8 is 16, times 5 is going to be 80, plus 2 times 11 is 22, or I could just say 10 times 11, which is going to be 110. All right, just go ahead and add these guys together. So that's 286 plus 80, 366. Right? 366, what is that? Square yards. So, let's bounce on down then. Oh, yep, there we are. 366 square yards. Did it. Got them. All right. Let's see. Do we have any other ones on here that'd be a bit of a wrinkle? I don't think so. Like these are all relatively straightforward, right? In the efforts of spending just a little longer on this topic, I'll do one more really quick. I'll do this one here, number 6. Excuse me. That is another surface area question. So then surface area equals 2 pi r squared plus 2 pi rh. So now we know put them over here, right? We always declare our variables over on the side. So we've got, let's see, height is going to be 8 yards again. And then the radius is going to be 6 over 2, which is 3 yards, right? So it's just important to make sure that you're turning the yards into, turning the diameter into radius, right? Always got to make sure to do that. And beyond that, the question is just plugging stuff into the formula, really. Right? So 2 pi 3 squared plus 2 pi 3 times 8. 3 squared is 9, of course. 9 times 2 is 18, so that's 18 pi. Over here, 2 times 3 is 6. 6 times 8 is 48, so that's 48 pi. So then surface area is going to be 66 pi. And to get that one, I'm going to turn to the old calculator. Surface area is going to be 66. It would help if it was on. 66 pi. There we go. 207.35. 207.35 square yards. All right. And now we'll just scroll on down. Scroll back on down on my mathaids.com. Fancy dancy. Yep, 207.35. There we go. So another one off the practice sheet. Yeah, so Ashley, I hope that was helpful for you for the prism practice. Yeah, like I said, the next test that you're doing is not, just to repeat, is not going to contain triangular prisms, even though I did show you those in this past unit. Those ones will come back, though. You will have those eventually, just you're not going to be tested on those next, right? So if you would like to write your test for Thursday, you can let me know, although I'll be emailing you about that later. All right, so now let me pop on back over to my intro screen. Here we go. Stream starts soon. No, it doesn't. It's already started. So topics for today include the surface area of prisms. Did that. Graphing systems of equations. Okay, great. So that'll be the next one that we're going to do. If I become less occupied with math questions for streaming, will you turn into NL Science Man? Yes, yes, I will. I will morph. You'll see it on stream. I'll do it. You'll see me sort of shift and change. It'll be like a Doctor Who regeneration scene where like all this light shoots out of me and then all of a sudden I come back in a different form as NL Science Man. That's true. Now, to answer your question, Albert Einstein, the reason I picked NL Math Man is mostly just because like answering science questions um, doesn't tend to be as appropriate for stream content as often. I have been answering lots and lots of science questions. I actually probably have more students right now doing science courses than doing math. And that's great. Like I don't mind. I love students doing science courses. It's great. The same as the math courses as far as I'm concerned. Just the reason I'm doing the math on stream is because oftentimes math benefits from being able to see like the working and me walking through it step by step. Whereas the science, I usually just write up like paragraphs or whatever in emails and send it to people, which is not all that different than how I normally correct the science because I'm normally like writing out pages and pages of handwritten notes to to tell people about the science stuff they're doing. Now I'm just writing out loads of, you know, typed stuff. So honestly, it's saving my wrist a little. Save my wrist for more important things like raiding Blackwing Lair and Zul'Gurub. Anyway, now I'm going to go on to graphing systems of equations, like I mentioned. So let me see. Let me bring up the proper page that I wanted for those. Oh, oh, I appear to not have that file open. Hold on, just one quick second. Just bear with me a second there, Twitch chat. Some nice. So we got some good dead air here. This is how you know. This is how you know you're a good streamer or a good broadcaster or whatever. When you're there for like 30 seconds or so with nothing to say. It's like strong bads. Um, it's like strong bads. What was it? College radio. Yeah, dead air. Um, dead air. That's a reference exactly for me, right? I don't expect anybody else to ever get that. Okay, here we go. We're good. Crisis averted. Here we are. We've moved on now. We're going to go into graphing, and we see this here. This activity is the math 1101C. We see computer activity. So the computer activities. Okay, that makes sense. Keep any science questions for email if you're doing those courses. Sure. I mean, yeah, if you got any science questions, you can tell me on stream. Absolutely. Just occasionally, occasionally it won't be super appropriate for me to just walk through it on stream. Um, I will do them on stream though, if it makes sense. Like I have done some science questions on stream. I believe I did some Punnett Square examples for Betty Ann. Those on stream. I will definitely do science stuff on stream. I picked Mathman just because I don't know. I just needed something off the top of my head that was business sounding ish. You know, I didn't want to just use the same handle I use on Twitch all the time, right? Because it's just a nonsense word that would kind of not make sense. So, but yeah, I'm totally capable and willing to answer any questions for the science courses that we do. And the physics ones will be great on stream because I can walk through how to do those. But yeah, even biology or chemistry, I'll go down through those as best I can. Yeah, if any of the courses that I teach, you can reach out to me and I will get you feedback on those in some way or another. Right? But now I'm going to look at a little bit more at graphing systems of equations or solving them by graphing. Right? Now, again, I don't have. Oh, hi there, Slayer Darth. Teaching yourself math, chemistry, and physics. Okay, yeah, great. You've been busy during social distancing, huh? It sounds like a lot of work. If you got any questions, yeah, you can drop them in chat if you would like. I'll see what I can do for you. So this is going to be solving systems of equations by graphing. Hey, if you haven't tackled graphing in a while, that's good. You tuned in at a good time then, because I'm going to go down through how we're going to solve these Well, we're just going to find the point of intersection of these lines that we see over here on the right. Let me go back over to a different display and then zoom in a little bit so we can see it a bit closer. Standard form, slope, intercept, point, slope, etc. Yeah, exactly. Great. Yep. This is, if you're graphing by hand, I do recommend slope intercept form. I find that's the most straightforward. But you're welcome to use whichever of the forms you like. Now, where this one is by graphing, we're actually going to do it on Desmos.com. So it's maybe it seems a little bit like cheating, but it's actually going to work out really well. In question one here, uh, we've got x plus 2y equals -2. We've got x minus 4y equals 16. Now what I'm going to do, I'm just going to put these both into a form where we're going to get y by itself, right? Which is, of course, what we call slope-intercept form. So to do that, I'm going to get the x moved over to the other side here. So we'll call this 2y equals -x minus 2. Then we're going to divide both sides by 2. It's going to be y equals 1 over 2, -1 over 2x minus 1. Now, the reason I've written it like this, right? I could write this a whole bunch of different ways. I could write this as just -x divided by 2, or something like that. Or you could even write it as -0.5x. But I did it like this so that we can see more clearly the slope, right? Because we know the slope of a line, or gradient if you're British. But the slope of a line is equal to the rise over the run. So here now, we know that the slope of this line is going to go down one sort of block or one unit when it goes to the right 2. And we know its y-intercept is going to be -1, right? Because just as a quick reminder, y equals mx plus b is our sort of is the slope-intercept form, where m is the slope and b is the y-intercept. And if you're British, instead of plus B, it's plus C for whatever reason. But it's the exact same thing. Okay, so, and for this one over here, I'll just sort of do the same sort of deal. I'm going to move the y's this time. X minus 16 is 4y. 1 over 4x minus 4 equals y. And now I could go ahead and graph those by hand, which I'm going to do. However, if anyone's been watching my stream recently, or at all since I started, you'll know that I don't have any graph paper here. And with social distancing, I'm not too keen on heading out and getting more graph paper. So for now, I'm just going to keep graphing these by hand, and then we're going to check them on a calculator or on Desmos.com, which will help us a bit more to see exactly what's going on. So we've got, see, I'm going to make some gradations on here to make it at least somewhat standard. So I'm going to do 1/2 centimeter per, like so. And these are both minus. I'm going to go over to the right a bit with a few 1/2 centimeter notches as well. Not perfectly accurate, of course, but, you know, we're making do. So now our first line, oh, actually, yes, I should have done these in different colors. Hey, this is why I've got these multicolor pens here. So I'm going to do this one in red, and I'll do this one, yeah, I'll do them both a different color than the grid, I guess, just to make them stand out a bit more. So I'll do this first one here in green. All these answers are given in slope intercept. Well, that's just what I'm doing in order to show how to graph these. We can graph them from any form that you want, really. But I'm just showing how to rearrange them into that, and then how we're going to graph them like so, right? So I'm going to go, the intercept of this first one, or the one circled in green, is going to be -1. It's going to come through right here. And then our slope is going to be -1 over 2. So it's going to go down one block when it goes to the right 2. Down 1 to the right 2. Now again, this is, you know, this is super approximated, right? Because I don't have my graph paper here. Put an arrow on either side. Super important to have an arrow on either side here. because that lets us know that it's actually a line and not a line segment, right? Some pedantic math teachers will take off a half a mark or something for forgetting the arrows. Not to say that I would, because obviously I'm not. I'm not a pedantic math teacher, of course, right? I'm totally, totally easy to get along with. Don't know why I'm laughing at that. What sort of an indictment of myself is this? So now the slope is 1 over 4, positive 1 over 4. So I go up 1 and to the right 4. 1, 2, 3, 4. Up 1 to the right 4. Up 1, 1, 2, 3, 4. To the right 4. Then I graph it like this. There we go. Okay. So when we're told to, yep, 1 up and right 4 again, that's right. Because it's rise over run. So now we can see from looking at it, and we were told to solve these by graphing, right? And when we're told in this course to solve by graphing, I'm just going to get you to draw it out and then approximate like so, right? So we can see from this one, it looks like 4 minus 4 is our point of intersection. Now, how can we check that? Well, there's several different ways we can check it. We could have checked it by doing elimination method or substitution method, but for today, I am going to check it with an internet calculator. So I'm going to scroll on over here now. Here we go. Now we're in Desmos. This is a super useful program to use. This is desmos.com. I move my head out of the way. You can see powered by Desmos down there in the corner. Okay. So now to bring up my, let's see here. Oh, flip over to my screen for a second. Whoa. So now we're going to bring the sheet back up just so I can see to type them in. And we'll see over here that I'm going to type in now these exact lines. I could type them in the way that we rearrange them, but I'm actually just going to type them in the way they were in first, just to show you what Desmos can do, right? Equals -2. There's one of my lines. We'll see when I move the sheet back down, we'll see how these look, right? Then we have x minus, this is x minus 4y is equal to 16. A little bit awkward here because I've got to be moving my keyboard around to get it down out of the way. There we go. Minimize, minimize this one. There we go. See? This is how our lines look. Very similar to what I have drawn there. And we see that our point of intersection, there it is. It is indeed, it's 4 minus 3. Okay. There we go. 4 minus 3. We can also do it in say a TI-84 calculator, something like that. But Desmos.com is a super useful one to do, especially during distance teaching, right? Where you might not have access to the calculators like you would have in class. Yeah, Slayer Darth. Let's see what y to the y to the 1. Y to the 1 is the same as y, right? So I'm not entirely sure what you're writing out there. That looks to be y to the 1 minus y divided by x minus x. So it's y minus y over x minus x. Unless you mean for there to be a bracket on the top and the bottom, then it's just 0 divided by 0, which doesn't really work. So I'm not entirely sure what you meant. Betty Ann, yes, there was one here that you might have missed out on. Betty Ann, I think I'm now not to stress you out or anything. I think I'm waiting on the stuff from your test. Now that's almost certainly because you sent it to me and the emails just didn't work. But yeah, I'll let you know. I'll let you know when I've received all the different stuff from your test. Okay. Now, there are several different ways that we could check this one in ways other than graphing, right? For example, we could do, I'll just write one of these out over here. We could do, say, elimination method. Elimination method is super easy. You You sent all the questions? Yeah, I assume you did. I have only received one of them yet. It's probably because of email problems. I would recommend sending them only 1 or 2 pages at a time. That way, I'm it's more likely to get through, right? Because sometimes if your email is if like there's bandwidth problems or something like that, an email with a whole lot of attachments can get timed out sometimes, right? So, for example, for this one with elimination method, what we're going to do there is treat it like any system of equations, which means we can add or subtract sort of formulas from the other one, right? So I'm going to go ahead now and just write these two formulas out. And I'm going to subtract this whole lower formula from the top one. Well, how does that work? Well, we have our x minus x, which is going to make 0x. We have our positive 2y, subtract a negative 4y, which is going to make a 6y, or a positive 6y. Excuse me. Then we have a negative 2 minus 16. Negative 2 minus 16 is going to be a negative 18, right? Then once we've used elimination method and found this, now we can go ahead and find this y value, which is going to be a negative 18 over 6, which is, of course, going to be a negative 3. And hey, look, that is the y coordinate. The y coordinate of our intersection over here is negative 3, right? So now we can go ahead and find the x coordinate simply by plugging this back into one of the formulas. So I could say now that what I have is x plus 2 times negative 3 equals negative 2. So x minus 6 equals negative 2, or x equals 4. There we go. And if we go back over here to what we've graphed, we will see that indeed, yes, our point of intersection is 4, negative 3. Okay? But the useful thing is, right, when we're told to do it by graphing, like if we see the sheet here that I'm working on tells us specifically to solve, it's a computer activity to solve with graphing. So since it's a computer activity and they're asking us to solve with graphing, they are just asking for us to do, oh, haha, not that. That's not what they're asking us to do at all. They're just asking us to do this, right? Put it in there like that, and get 4 minus 3, and then also draw it out, right? You do need to draw it on your activity. So on your assignment, down here, you would draw out the lines on there. Okay, I think I've got, yes, I had another question. I wanted to do number 4 off this sheet as well. Okay, this is a good one. This is a good one because it's got a bit of a wrinkle here. It's not quite the same as what you might be expecting. Sip of my coffee. It's not instant coffee. It's not. No, yeah, I know a few weeks ago I was complaining that all I had left was instant coffee. I have managed to get some grocery deliveries, despite social distancing and all that. And one of the things I got was some, I was going to say some nice coffee. Some acceptable. Some perfectly acceptable coffee. All right, so let me go back over to this display. Move this and zoom in. There we go. So I'm going to do question 4 here now. Let's get another sheet. This is still solving. This is still solving systems of equations by graphing, and this is going to be question 4. Okay, so we've got 2x minus 3y equals 6. And then we've got 2x minus 3y equals 12. Actually, I'm going to go ahead and do most of the workings for those in color instead of just circling it at the end just so we can see it a bit better. So I'm going to go ahead and, like I said, I like to rearrange these to being slope-intercept form. So I'm going to call this 2x minus 6 equals 3y. then I'm going to call it 2 over 3x minus 2 equals y. Okay. This one over here, I'm going to do the same sort of deal. I'm going to call this 2x minus 12 equals 3y. That's going to be 2 over 3x. Oh boy. Hold on a second, please. I honestly don't even know why I have a landline, to be perfectly honest. Like, I never get called. I just looked over and it was just some random nonsense number. I never get called to my landline for anything serious. Like I don't even give the number out. I don't use it. I use my cell phone constantly. Why do I even have this? Just because it's like bundled in packages with like internet and stuff, right? I don't know. Like getting a call, getting a phone call instead of a text message. Boy, what is this? What is this? 1998. Anyway, this guy's a this guy's really old. He's talking about using a landline. He also does a bad impression of Jim Gaffigan. Hot Pockets. Okay. I'm going to go ahead and mark these off in sort of half-centimeter notches, just to give us a bit of standardization here, even though it's not perfectly exact by any means. Found your old algebra PDF, going through the graphing section. Oh, cool. Yeah, nice. Yeah, if you're working on keeping up to date with your math work while you're off school for social distancing. I am live every weekday at it's actually 1 p.m. Newfoundland Standard Time or Newfoundland Daylight Time, I believe we are now. But either way, that's 11:30 Eastern. So if you got any questions on whatever topics you're doing, not in school, okay. I mean if you just want to practice some math, it's cool to stay and hang out. So to teach yourself math, chemistry, and physics from scratch. Been at school for a few years. Sure. Yeah, I mean, any intellectual curiosity for sure. Yeah, I'll definitely help out with that. Yeah, it's great. Yeah, it's a noble goal for sure. Always, and this is a good time for self improvement too, right? It's tough to be out doing a lot of things in the outside world these days, but it's a great time to stay home and to work on work on your knowledge base, right? So I'm going to go ahead and graph the two of these guys. So the one in red, the first one, I'm going to go down to minus 2, and it's going to be 2 over 3. So we're going to go to the rise over run, up 2, to the right 3. And then, oh, I need some gradations above as well. Hold on. Like so. Up 2, and to the right 3. So say about here. Now, what do we notice about these two lines? We've probably already noticed it. One very important thing about these two lines is that the slope on both is the same. And if two lines have the same slope, well, what does that mean about them? We go up 2 to the right 3, up 2 to the right 3. Take these and draw it out. Look at that. Now, I've drawn this fairly close to right, I think. It doesn't look like those are ever going to cross, does it? And no, they're not. They're not because we know lines, yeah, exactly, parallel. That's right. Lines with the same slope are parallel. And because of that, these two guys are never going to cross, right? So if I was to go over and graph it, like on technology, because that is what we've been asked to do in this assignment, we pop back over. Here we go. So I'm going to go and write them up like they were written first. So we're going to see, I'll let you see it move in while I'm doing this. So we're going to have 2x minus 3y equals 6. There's 1. And then we have 2x minus 3y equals 12. There it is. Now we can see from this, well, we can also see, look, you can see my chroma key going a bit crazy with my eyes there. Look at that. Whoa. Okay. Okay. We can see from this that these guys are never going to cross, are they? They don't. Let me zoom out. I mean, if I zoom out this far, it kind of looks like they're crossed, but they're not. It's just because I've zoomed out so far that the space between them kind of disappeared. But those lines are parallel. They have the same slope. So there are no points of intersection for those two lines. So over here, we can say no also remember you have some weird lines in graphing, like undefined slope. Ah, yes. Um, Lines with no rise have a zero slope. Lines with no run have an undefined slope. Exactly. Yeah, that's exactly right. Because, of course, we know that slope is equal to rise over run, right? So if something has no rise, it's going to be 0 over some number, which is always going to be 0, right? Doesn't matter what the run is. If there's no rise, your slope is going to be 0. But if you have no run, it's going to be x over 0, which is undefined. Right? Kind of crammed it in on the edge of the page there. But of course, we can't divide by 0, right? That causes black holes, so you should never do that. Yeah, x over 0 cannot be quantified. That's right. That's right. Because basically what we're saying when we're dividing by 0 is we're asking, well, how many sets of size 0 can I get out of another number? And the answer is it's as many as you want, right? And the answer is not infinity here in this case. The answer is just undefined. So like you say, yes, a vertical line has an undefined slope. A horizontal line has a 0 slope. Okay. So that is mostly what I wanted to get to today with the graphing. Let me pop back over to my intro screen. Here we go. So I want mean, median, and mode word problems. Okay. This is, so Betty Ann, hopefully that helped out a bit there with your graphing questions. I'm going to pop over now to a few questions for Esther. That will be, let's see here. Ah, this is a good page. Yeah. This is a topic you like? Okay, great. Yeah, good stuff. So then let me pop over to my document display here. Okay. So the first thing we're going to do for this topic is we're going to construct a stem and leaf plot for each of the following. Use the state, the median, and the mode. Okay. So now, remember that one of the first things we've got to do whenever we're finding a stem and leaf plot or median and mode, I need to Google how to calculate standard deviation real quick. Yeah, I like standard deviation. That's a good one. We actually don't do standard deviation in any of the courses that I teach currently, although I have done standard deviation was like the main thing I taught in the occupational health and safety math program that I did a while back. Yeah, sure. You can. How about you race me to the answer? There you go. Yeah, get me that answer number 15 down there. All right, so this is going to be math 3102A unit 2. Right, and this is question 14 here. So the very first thing I'm going to do is I'm going to copy out all the numbers that are there. And I'm just going to copy them in the order that they're there, just because I want to have them written on my paper. It's going to be 40, 38, someone, reading out a series of numbers. It's very engaging streaming content, right? 62, 73, 55, and so on. There we go. Okay. So now, what we know we need to do whenever we have a mode is 76, we've got a 76 and a 76. Yeah, well, there's two of them. Are there two of any other number? I don't know. We'll see. But now when we do a stem and leaf, right? Generally, what we're told to do to make a stem and leaf plot is to do it twice. We do an unordered one first, and we do an ordered one second. Right? So I'm going to do unordered first. My unordered stem and leaf. It's made simple mistakes. Yeah, it's easy to make a simple mistake here and there. On Betty Ann, I do have all the. Can I do a redo? No, that assignment was not worth very much, and you got 100 on the assignment that was worth quite a lot more. Anyway, I've got it all done up. I'll send that to you along with the notes from today's stream after I'm done here in like, I don't know, half hour or whatever until until I get through all the topics I've got. But now this is going to be our stems, and this is going to be our leaves here. And again, right, I'm not going to be concerned with ordering them here now, but I am going to keep the stems in order. So we've got 40s, 30s. So we've got 30s, 40s, 50s, 60s, 70s, 80s, and 90s, it looks like. So I'm going to have 3, 4, 5, 6, 7, 8, and 9 for my stems. Then I'm just going to go through and mark these guys off in the order that they're there. Right, so 40, 38, 2. It's a little bit of, I don't want to say legwork. It's a little bit of, number crunching, bit of wrist work. Go through and get these just written out like this. $71, almost there. 84, 66, 72, 56, and 43. And just to remind you, right, like a stem and leaf is basically a way that we organize a whole bunch of numbers in a smaller space. Right? Actually, let me switch back over to this display. We can't see the other page quite as well, but we can see what I'm working on a little bit bigger. So now I'm going to have the ordered. This is going to be my ordered stem and leaf. Stems and leaves here. Go through and do these in order now. So we've got 38 as the first, 40 and 43. 5 is going to be 3, although the 5s were already in order. 6s are not in order, so I've got 62, 65, 66, and 69. Then the 70s are going to be 70, 71, 72, 73, 76, and 76. It's going to be 80, 82, 84, and 87. It's going to be 92. Okay? Not sure why. This old life cam. I keep saying stuff about this camera. I'm not quite sure why it seems to keep getting darker. Right? Like I up the brightness, and then a little while later, it's like, hey, how about the brightness goes back down instead? And I got to be like, all right, well, I guess that's okay. Okay, let's pump up the brightness a little bit. So now we've got our ordered stem and leaf diagram, but there's one more thing we got to do. It's super easy to do, and it gets you like 1 mark out of 4 on your question, is you always have to do a key. Right? So my key here, say 3 bar 8 is equal to 38. That's all I got to do. So a key just shows the person reading your stem and leaf diagram, what the values are going to stand for. Okay, so it is always important to have a key. I know in this question that we see over here, you can see my cursor. Yeah, I know over here they only really give you space to do one stem and leaf, but you can definitely go and write it out on a separate sheet of paper to get an ordered and an unordered one. Okay, median is 70, the 11th number. Ah, well, let's find out. Let's find out. So the median, well, how are we going to find the median? Well, the median is the middle number, right? The middle number in order. So it was important that we put it in order first. There is a sort of a shortcut way to find which number is the median, and that's n plus 1 over 2, where n is the number of numbers that we have. So how many numbers do we have here? Let's see. 1, 2, 3. 21. 21. So yes, indeed, it is. This is the median shortcut. That's right. So 21 plus 1 over 2 is just going to be 22 over 2, which is going to be 11. So it's the 11th number. And the 11th number in order is going to be n is equal, you divide by 2 and get the average of the two middle numbers. Exactly. Yes. Yeah. Sounds like Slayer Darth. You're ahead of this topic for sure. You know that one. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the median is indeed 70. Right? Yeah, if n is even. Yeah, that's right. If there's an even number of numbers, there's 2 in the middle, so then we take the mean of those two, or the average of those, just find the number that's in between those guys. So now the mode is just the most common one, and once it's written out in an ordered stem and leaf, finding the mode is super simple, because it's just the only number that has the most by it, right? So that's going to be 76 here. This one doesn't really show the edge cases. There are sometimes we'll be sneaky because teachers like to pull a sneaky on you and do stuff like have 2 or 3 numbers that have 2, right? Wonders why they use n as a placeholder. Yeah, n is just it's the number of numbers, right? It's um, sort of the most common one to use for that. But whatever letter we use is really just arbitrary, to be honest. Okay, so I want to do numbers 15 and number 16 off of this activity as well today. So let's move on here. Number 15, then down just below, is a weighted mean question. Calculate the mean and weighted mean. So let me go over to the different display. We can see it. Yeah, now we can see it good, nice and clear. Yeah, yeah, yeah. That's how I think of it anyway, as it's standing for number. Yeah, the number of numbers, basically, right? So now, this is still going to be math 3102 a unit 2, still the same unit. Question 15. This is going to be calculate the mean and weighted mean for each of the following. Now, they give us, so yeah, I guess I need to draw out the whole chart, don't I? So just bear with me for a second. So we need 4 columns. Oh, going to need a bit wider, aren't I? 4 columns and then 2, 3, 6, 7 rows. Okay. Coursework. Weighting. Mark. And product. So all that weighted mean is, honestly, weighted mean questions are sort of funny because it's kind of like a teacher giving a little peek behind the curtain because weighted mean is exactly what teachers use to figure out your average mark in like every course ever, right? Oh, thank you. You're getting ahead of me there, but thanks very much. I'm gonna copy those ones down now in a second. So homework. Whatever. Hopefully your mental arithmetic is up to scratch. Well, mental arithmetic is it's a real skill. It's a great thing to practice too. It's all about finding ways to make the math easier, right? It's all about making things as easy as possible. Like if I was doing 5 times 85, well, you could do 10 times 85 and take half of it, or you could do say 100 times 5 and take away 15, right? Or take away 15 times 5. I mean, you know. So or 80 times 5, say, right? Like 80 times 5 is going to be 400. 400 plus 25 is going to be 425. Oh, really cool way to calculate large exponents of numbers. Sure. Yeah, lay it on me. What do we got? 20 times 75. I'm going to keep filling these guys out. Oh, using the binary system. Okay, sure. So it's going to be 20 times 75 is going to be 1500. That's right. 25 times 70. Um, well, 20 times 70 is going to be 1400. 5 times 70 is going to be 350. So yeah, 1750. 20 times 72 is going to be 1440. Yep, that's right too. And then 2040. So that's going to be 30 times 70 would be 210. 210 minus 60 is 2040. Yeah, great. Excellent. Right? But what we're actually doing, or what we're trying to figure out when we're doing weighted mean, is sort of like each of these marks is worth a certain amount. And you'll notice that when we go through and we total these guys up here, these are going to equal 100. And that's extremely important here, right? Because, of course, we're trying to get a percentage mark overall, right? But yet not every piece of work that the student does is going to be worth the same thing. Now down here for the total marks is not super important, except to find the normal mean, right? Because we're looking to find the mean here, and we're looking to find the weighted mean. Over here, right? So to get the mean mark, well, what do we got to do? We know that the mean of anything is the sum of the numbers divided by the number of numbers, right? And sigma here just means sum of. It's a Greek letter, sigma, not to be confused with the villain of Mega Man X. So the sum of n, or the sum of all these numbers, divided by the number of the numbers, which in this case is going to be, let's see, 85 plus 75, 70, 72, and 68. Could have done that in my head maybe, but we'll just go ahead and skip it. It's going to be 370 divided by 5. So it's 370 there. Divide that guy by 5, and we get 74. So 74 will be the student's average mark if all of these things were equally important in the course, right? Which they're not, and they generally aren't, right? Because teachers will set up something like this so that, say, midterms and finals are of course worth more than say an average assignment or something like that. And doing a weighted mean now is the way that we can go ahead and have certain things worth more than others, basically. It's going to be 7155. So the weighted mean then is going to be the product divided by the weighting total, right? It's going to be product over the total. That symbol is sigma. right? It's a Greek letter that means sum of, right? Sigma, like yeah, yeah. Like in Mega Man X speed runs where you gotta like hit him with the Hadouken when he comes out with his lightsaber. It's good. It's good stuff. Uh, it's a totally different thing. I'm not gonna do Mega Man X speed runs on stream. I would it would be terrible. It would not look good. I'm not practiced at all. Uh, Need to find a good reference of all the Greek symbols they use in math equations. Yeah, I mean a good math textbook could do a lot of that for you. Seeing you're teaching yourself, there are some. I mean, Khan Academy is yeah, like the delta triangle. Exactly. Yeah, that's a delta meaning change in is a super useful one. There's loads of great online resources for math. Math is fun. Is a great website. I know it sounds a little juvenile from the name, but they actually have some pretty sophisticated tutorials on there. Um, I would really recommend Khan Academy if you're teaching yourself. Just go through and do one of the quizzes where they try to place you to figure out sort of where you're at already. And yeah, it's pretty good actually. Once you go through like their system and it sort of targets you into what you know already and what you don't know, it actually goes all the way up through a lot of like undergrad, college level, and university math. And yeah, it is really useful to targeting you toward which topics you need to learn more on. It's not a one-stop solution to math education, but it is a really good tool. So we've got 7155 divided by 100, which is, of course, going to be 71.55, or, about 72. So the student's mean mark for this one, if we just went ahead and added them all together, right? It would be 74, but with the weighting, counting the tests and midterms and finals a bit more, it ends up being about 72% for that course. Okay? So let's see, there's one more that I want to get to in this. Actually, no, maybe we'll do 16 and 17 over here because I know Esther asked specifically about 16, so I'm definitely going to do that one. (3102A) Unit 2 still. And this is question 16. In question 16, we're told the table shows the number of hours that Caitlin worked for the last 8 weeks. Her mean number of hours is 25. How many hours did she work during the 8th week? Right? So this is a really, really, really common type of sort of twist question to sort of test and see if you understand sort of the fundamentals underneath how to do mean questions, right? But we know that the mean, right, like I just showed, is the sum of all the numbers divided by the number of the numbers, right? So what can we fill in here? Well, what can we know about this one, right? Well, we know that the sum of the numbers, once we bring it over here, let me switch my displays. There we go. We know that the sum of the numbers is going to be 19 plus 27, 18, 20, 29, 23, 28, and then this one n that they don't. It's a bit, okay, I'm just going to call that x, actually, instead of n, because Slayer Darth, you are right to point out that we use n to mean specific things. Just whatever the teacher was that made this one, put an n in for the variable here as well. So I'm just going to change that one to be x instead. And then I'm going to divide by the number of numbers, which in this case is 1, 2, 3, 4, 5, 6, 7, 8. And now we know, because we're told the mean in the end, we're told over here, we can see them with my cursor. There we go. Mean number of hours is 25. So we put our 25 over here. Now we can go ahead and start simplifying this. Right? But how did I get to this? because getting to this is like not even half the battle. This is like 85% of the battle. Because we know that the mean is all of the numbers added together, divided by the number of numbers, gives us the mean, right? We're told the mean is 25, and we're told 7 of the 8 numbers. Now, we don't know all of them, but we know these 7. So once we've realized that it's all the 8, the 7 known, and the 1 unknown, all of those added together, divided by 8 gives us 25. Now all of a sudden we've got one equation with one variable. One equation with one variable we can solve, right? Although this is just coming from a course where we had 2 variables, but we had 2 equations, right? So if we have 2 variables and 2 equations, we can solve. In this case, we have 1 variable and 1 equation, which means we can solve as well. So now I'm going to go through and start adding these guys. 19 plus 8. There we go. So this is 164 plus some unknown number divided by 8 gives us 25. So I'm going to do this one step at a time. Now we're trying to get x by itself. So from this point on, it's just really a normal algebra question where we're just rearranging stuff to get rid of it. So 164 plus x is equal to 8 times 25. I'm just going to show it a little more slowly here. 64 plus x is going to be equal to 200. Of course, 8 quarters, $2, right? Easy. So then x is going to be 200 subtract 164. So x is going to equal 36. So we know then how many hours did she work? Well, we know that Caitlin worked 36 hours. There we go. Okay, so that's number 16. Esther, I know you asked about that one specifically. I haven't had a chance to take a look at your work to correct it quite yet. I'm going to be getting into that as soon as the stream ends. I'm going to go straight back to the correcting desk and get a few hours of that done. But yeah, I imagine that the issue you were having was with getting to this point at the start. That's just to remember that, remember what the mean is basically, right? It's the sum of all the numbers that we have divided by the number of numbers gives us the mean. And once we've got this, we can start simplifying it down. And from here on down is it's just an average algebra question. Okay, and then for the last one I'm going to do, I think, I'm going to do this one here, number 17. Uh, 3102A, and this is still unit 2. So we're going to calculate the 25th, 50th, and 75th percentile for question 17 here. Okay. Now, what are the numbers that we have? Are they in order already? No, they are not. Okay, so the first thing we got to do whenever we're doing a question like this is put the numbers in order. So I'm going to put that here in capital letters. Got to be in order. It's going to be 32, 56, 78, 62, 81, 96, 73, 84, 97, 81. Okay, so I'm just going to start putting these guys in order. So looks like 32 is the lowest one. Then the next lowest, boy, that 32 is a real outlier here, isn't it? Next lowest one is going to be 56. So those were in order. Then it's going to be 62. Then it's going to be 73. Then it looks like 78. Then 81. Then another 81. Then an 84. And then a 97. Okay, did I skip any numbers? 1, 2, 3, 4, 5, 6, 79, 10 numbers. 1, 2, 3, 4, 5, 6, 79. Oh, I did skip a number. Crud. Oh, there's a 96 there. Always good to check. See? Always good to check. You can make an error in something as simple as just copying numbers down, right? Like these things happen. These things happen on tests, and you'd lose a solid like half the marks probably, or at least 1 out of 3 for getting that wrong. And all it was copying down numbers. Like, you know, it's easy to get right, but it's also easy to get wrong. So always check it, no matter how pedantic or boring it seems. So the first thing I'm going to do here is get the 50th percentile, because we know that the 50th percentile is the mean. All right, we know that. So the mean, oh, I'm off kilter here now. See? It's the median. It's not the mean. It's not the mean at all. It's the median. Of course it is. I'm a little bit disheveled all of a sudden. So to find the median, it's just going to be n plus 1 over 2. Here n is 10. So 10 plus 1 over 2 is going to be 11 over 2, which is going to be 5.5. And now, like Slayer Darth mentioned there a few minutes ago, now indeed we have a situation where this is the fifth number, 5.5th number. There we go. But it's the number in between the 5th number and the 6th number, right? So the 5th number here is 78. 6th number here is 81. So what we want to do is we want to find the number that's directly in between 78 and 81. So in this case, it's going to be 78 plus 81 divided by 2, which is going to be, was it 159? 159 divided by 2, which is going to be, it's going to be 79.5. Okay, there we go. So 79.5 is going to be the median. Now, we'll get the other two ones. So the 25th percentile is the median of the lower half of the numbers. So the 25th percentile, median of the lower half. I'm going to do that in blue over here so we see it a bit different. So 25th percentile. Now, there's several different ways that we can go about doing this. And if there's a large set of numbers, what we would do sometimes is like multiply 0.25 by n to figure out which of the numbers in the full set it's going to be. That's one way we could do it if we had a really, really big set of numbers. But with these small sets that we have in this course, we're actually going to do it a little bit simpler, and we're just gonna kind of count and see it, right? Because our lower half of the numbers are going to be these ones circled in blue, which are going to be all the numbers that are lower than our median, and all the numbers that are lower than our median are these ones. So we can see that the number in the middle, well, here there's 5 numbers, so it's going to be 5 plus 1 over 2, or it's going to be 6 over 2, which is going to be 3, right? So here, our 25th percentile is going to be 62, right? Because it's this number here. Oh, Slayer Darth, yeah, the percentile, the 25th percentile is otherwise known as the lower quartile. And this is really useful in stats. Say if you go on to look at, say, box and whisker plots. Box and whisker plots are a very good way to represent the spread of a set of numbers. But what this is it's the lower quarter of the numbers here. Not from the US? Okay. I mean, neither am I. But a lot of our terms are American centric, I suppose. But yeah, so here, the 25th percentile is going to be the median of the lower half of the numbers, right? So we can see here, our lower half of this set is 32, 56, 62, 73, and 78, right? Because those are all the numbers that we have that are lower than the median. Oh, never used to understand what they meant when they said the students in the 98th percentile. Yeah, yeah, we'll see that. We'll see kind of like that in question B. But if you're in the 98th percentile, what that means is your mark is higher than 98% of your peers, right? It means there's 2% of people are above you, 98% of people are below for grade, right? So it doesn't necessarily mean that you received a score of 98%. You may well have, but it doesn't. I mean, a score of like 65 could be in the 98th percentile. I mean, hopefully not. Hopefully not. But yeah. Yeah. So what it is it's a comparison basically, right? So here, 62, 62 is not 25% of say the numbers of the maximum number here. 62 is not it's not even 50% of the median, right? But what it is it's the number that's in sort of the 25th percentile, in that 25% of the numbers are lower than it, 75% of the numbers are bigger than it, right? So if we go over here, the 75th percentile is the median, the upper half. So the easiest way to calculate the percentile, work out the median and multiply divided accordingly. Um, well, if we're looking at the percentile of a number, I'll show you that here now in a second in part B. But we'll see that basically you have to figure out where that number would go in the set in order, right? Because it doesn't actually matter what the number itself is. So say for part B, when we're saying what percentile is a score of 73, the fact that the score is 73 is not super important. What is important is where that score of 73 would be in this spread of numbers here. Because 73 is like a fairly good mark on a test, pretty much any test. Like 73 is a B, right? We take those. We're not super sad to get a 73, but in this set of numbers, 73 is not a super great percentile here. But you'll see in a second there. So now the 75th percentile. Again, right, we've got six numbers, or five numbers rather, because we've got the five numbers that are all bigger than the mean. So this is the mean, and all of these numbers are larger than the mean. So 75th percentile, 5 plus 1 over 2, 6 over 2, is the third one of these in order, and we can see the third one of those in order is going to be 85. So 84, sorry. 75th percentile, also known as upper quartile. Right? Excuse me. So now I will go do 17B here. All right, so that was 17A. So 17B, what percentile is a score of 73? Well, now, so this is what we were just talking about, right? So how do we find out the percentile of a number? Well, in this set, this looks like, say, a set of test scores, probably, or something like that. But teachers, test scores are sets of numbers that we deal with all the time. So here now, we can see that a 73 is already in the set, and it's number 4, right? It's number 4 in order out of 3, 4, 5, 6, 7, 9, 10. So 73 is going to be the 4th number out of 10 numbers total. So in this case, 73 is going to be 4 out of 10, which is the 40th percentile, or 0.4, right? Which equals the 40th percentile. Seems a bit harsh to say that it was in the 40th percentile, but percentile is always a ranking based on the other, based on the peers, basically, or based on the other results, right? So in this case, even though 73 is a perfectly fine mark, the person ended up being in the 40th percentile with a score of 73. Say on this one, let's imagine someone had a 95, right? So let's imagine there was a 95 sort of inserted in there. So a 95 would be, so if there was a 95 just added into here, say someone else did one, and we wanted to determine what percentile they would be in, 95 here would be 1, 2, 3, 4, 5, 6, 7, 8, 9 will be the ninth number out of, well, there would be 11 then, because say we added another 95, right? It would be the ninth number out of 11 total. So 9 out of 11 is going to be, oh, sliding off my page. 9 out of 11 is going to be the 82nd percentile. 0.82, which is the 82nd percentile. So obviously a mark of 95 is really, really good. Like anybody who gets 95 on any test should be proud, right? But here, in this case, because someone else wrote a 96 and someone else wrote a 97, the mark of 95 actually ends up being in the 82nd percentile. Because what that means is 82% of the people who wrote the test were lower, and then the remaining 18% were higher, right? And so, of course, a consequence of this is that the smaller the set of numbers is, the sort of more extreme the difference between the percentile rank and the sort of numerical rank is going to be. So that was, yeah, that was everything that I wanted to get to today for the topics that I had to cover. Yeah, thanks for hanging out and chatting. Slayer Darth, yeah, I appreciate the banter, being able to talk about the math while I'm doing it. It's really great. I actually do this as part of a service to my own students during social distancing. But if you've got any questions at all, feel free to drop them in chat and ask them at any point. Like I said, I am live 5 days a week out here doing some corrections and doing some tutoring for my students. And yeah, anybody in Twitch is welcome to drop in and to join in on the learning. Very glad to have you. So let me just flick on back over to my intro screen so you can see one more glance at the adorable doggies. Yeah, so that was surface area of prisms and cylinders, graphing systems of equations, and mean, median, and mode word problems. Right? Okay. So, yeah, if you got any questions, I'll be back 11:30 Eastern, 1 p.m. Newfoundland Daylight Time tomorrow and all week there, and then probably, yeah, probably I guess up until the end of June when we adjourn for the summer. Right? So thanks for hanging out, and yeah, hope to see you again tomorrow. And yeah, stay safe. And need to brush up on your geometry. Okay, cool. Yeah, I've got several students doing geometry, so maybe I'll prep a little bit of geometry stuff for tomorrow. I'd say. So we do have it's a super common topic. So yeah, I'll come back with some more geometry stuff tomorrow. Although I know Ashley is working on geometry stuff right now, and so she'd probably appreciate some more tutoring as well. Yeah, but I hope social distancing is still going well for everybody. Staying safe out there. Right? Site you use for studying math? Wisent.com. Oh, excellent. Okay. I haven't seen that one before. I will definitely check that out. Yeah. More resources are really useful because of course, I was teaching an on-site program until, COVID-19 sort of reared its ugly head and we had to switch to a distance mode very quickly. Just so happens that I knew how to set up a Twitch stream, so here I am, right? But yeah, any other online resources and stuff is super useful for me. So thank you very much. I will check that out as soon as we're done here. All right. I don't mean to leave don't mean to leave so soon. I mean, like a 2-hour stream seems pretty short for a Twitch streamer, but I do do have other teacherly duties to go attend to. But yeah, thanks for the thanks for the suggestions, and I'll definitely look into that. Stay safe and keep interested. Keep interested in learning math. And I'll be back tomorrow if you got any other questions.